Hello, my name is Yariv Cohen and I'm Head of Research and Development at EasyMining Sweden. In this presentation, I would like to talk about a new technology for phosphorus recovery from sludge ash. I would like to start by telling a little bit about EasyMining Sweden, who we are. EasyMining was founded in 2007 and at the moment we are about 28 employees. We are a daughter company owned by the Ragn-Sells group. We are located in Uppsala, where we have the R&D, sales and marketing. In Gothenburg, we have the engineering and sales. And in Berlin, Germany, we have also an office with sales and marketing. As I said, EasyMining is a daughter company in the Ragn-Sells group. Ragn-Sells is a big Swedish recycling company. Which treats about 6.3 million tons of waste per year. In the group, we're active in 4 different countries, in Sweden, Norway, Denmark and Estonia. We operate around 96 sites and we are about 2,300 employees in the group. In EasyMining, we work with the development of new technologies for recovering of commercial products from wastes. We are commercializing 4 technologies, ash to phos and ash to salts, that are about recovering commercial elements from ashes. We have CleanMap, which is a technology for energy efficient production of monoammonium phosphate. And we have also a process for nitrogen recovery from wastewater. In this presentation, we would like to talk about our ash to phos technology, which is about phosphorus recovery from incinerated sewage sludge. I would like to start first with a little bit background why it is important to recover phosphorus from sludge. In Europe, we have a single rock phosphate mine in Finland that provides about 10% of the phosphorus need in Europe. And about 90% of the phosphorus is imported to Europe from outside of Europe. And in general, there are 3 problems associated with that. One problem is that rock phosphate is a non-renewable resource with a limited lifetime. Another problem is that the rock phosphate has generally can have a high content of contaminants, mainly cadmium and uranium. And the third problem that I mentioned before is that Europe is heavily dependent on import from outside of Europe. In the picture here, you can see a little bit about the statistics. When fertilizers are used in agriculture, we grow crops and it becomes food. And phosphorus with the food ends up in the wastewater treatment plant. There it is efficiently removed and ends up in the sewage sludge. In Europe, about 50% of the sludge is spread directly on agricultural land, and about 25% is being incinerated, mainly to reduce its volume and weight by 90%. And in the statistic, about 27% is not really defined. Even though in the Europe about 25% of the sludge is incinerated, the extent of incineration varies very much depending on each country. As you can see here, in Netherlands, Switzerland, Belgium, Germany, there is a large extent of sludge incineration, and in some other countries like Sweden, for instance, there is almost no sludge incineration. In this picture here also you see the trend from 1994 to 2014. And you can see that the extent of sludge incineration is increasing, and it, of course, continues to increase until today. The number today are much higher than are here in this graph. And our ambition is, once the sludge is being incinerated, the phosphorus ends up in the ash. The ash has a high content of phosphorus, but it contains also iron and aluminium coagulants used in wastewater treatment, also heavy metals. And the ash is disposed in landfills as a rule today. But with ash to phos technology, we can process the ash to recover phosphorus in a clean form, and by that close the cycle for the phosphorus loop. There are several countries that have already taken political decision on mandatory phosphorus recovery, and by that created a market for recovering phosphorus from sewage sludge. Germany is a good example. In Germany, a political decision has been taken that for all wastewater treatment plants that are above the size of 50,000 person equivalent, you will be obligated to recover phosphorus in 2029. And this means that 2/3 of all the sludge in Germany will be obligated to recover phosphorus. And Germany is the country in Europe with the largest amount of sewage sludge. And of course, there are other countries that have the same political decisions, like Switzerland and Austria. A little bit about the ash to phos process. Sludge ash has a high phosphorus content. It's about 10% phosphorus by weight, but it contains also iron and aluminium and heavy metal and other unwanted substances. And the ash to phos process is similar to treatment of rock phosphate. We start by dissolving the ash with an acid, and this chemicals, we use both acid and lime. We recover phosphorus in a clean form that can be used for agriculture or for feed phosphates, and we separate the heavy metals for disposal. The iron and aluminium we can recover separately to be reused as coagulants in wastewater treatment plants, and we have a non-dissolved silica sand which can find application in the cement and concrete industries. A little bit about the recovery rate. In the picture here you see sludge ash. The red color indicates a high iron content. Recovery rate for phosphorus is high, 90–95%. Aluminium is also high, 60–80%. Recovery rate for iron depends on how much acid we dose. If we focus on phosphorus, then the recovery rate for iron is low, 10–20%, but we can, of course, with increased acid dose, increase the recovery rate of iron to over 90%. And recovery rate for calcium is generally high, 80–90%. A very important aspect of this technology is that it detoxifies the phosphorus that we recycle. Even though sludge ash has a high content of metals and heavy metals, the recovered phosphorus is very clean. In this table here, you see the heavy metal content in the ash compared to the recovered phosphorus product. And you can see that for all the heavy metals, we have a very high reduction that is above 96%. So the recovered phosphorus product is very clean. I would say it's the cleanest phosphorus raw material on the market.
My name is Sara Stjernström, and I'm the product manager at EasyMining. And I will talk a little bit more about our products, and especially the phosphorus product. Ash to phos results in clean, well-known products, where the input chemicals becomes part of the final product. And actually 95% of the product from the process can be used. The phosphorus product is a precipitated calcium phosphate, PCP, and this can be used directly as a fertilizer or a feed phosphate, or it can be converted into MAP, SSP, DCP, and MCP. We also get precipitation chemicals, and these are iron chloride and an aluminium product. Finally, we get the silica sand, and this sand could, for example, be used as cement replacement when you make concrete. If we then look into the key parameters for our phosphorus product, you can see that the phosphorus content is about 16–17%. The calcium content is about 35%, and the dryness is 95%. I would then like you to look at the purity of the product, because this is a very clean product. And here you can see, for example, that the fluorine content is really low. It's below it's about 0.014 milligrams per kilo PCP. And I would also like to show you that the cadmium content is also really low. It's below 0.1 milligrams per kilo PCP. If you also look at the metals, you can see that in general, this is a very pure product. Then I would like to show you these solubility results. And here you can see in the light blue bars, the water solubility of the products. And we show both the PCP, but also here the PCP converted to DCP. And the water solubility is low, both for the DCP and for the PCP. If you then look at the light green bars, here you can see the ammonium citrate, and the DCP is fully soluble in ammonium citrate, while PCP is about 80% soluble in ammonium citrate. If you then look at the yellow bars, you can see that both the DCP and the PCP are fully soluble. And we also show here bars showing the total P content. And here you can see that the PCP was 16% and the DCP 19.8%. In this last slide, I would like to show you our feed tests. And as PCP has the same solubility as MCP, conventional MCP, it has the same solubility in citric acid as conventional MCP, and it's extremely low in fluorine. This could actually be a great feed phosphate. And so an action from us right now is to test the PCP in digestibility tests. And here we use pigs and poultry. And we also have legal discussions together with the European Phosphorus Platform, ESPP, to look into the legal barriers in the feed phosphate legislation, or in the feed legislation in general. And the next step from us will be to do a risk assessment together with EFSA, which is the European Food Safety Authority, to show safety with our product so that it could be used on the market. And the results from these tests will be presented later this year.
Hello, my name is Christian Kaber and I'm the Managing Director of EasyMining Germany. I'm about to present the rollout plans we have for our ash-to-phos technology in Europe. We are now at the brink to the market, and we have two concrete implementation projects in the pipeline, one in Germany and one in Sweden. In Germany, we are partnering with Gelsenwasser AG, one of the biggest water and wastewater utilities in the country. And we will have the first installation in the south of Berlin with a capacity of 30,000 tons of ash per year, or producing 15,000 tons of our calcium phosphate, which is more or less comparable also to 2,500 tons of phosphorus per year in the matrix. We are currently concluding the basic engineering and are also planning to file the permit application before summer. And our plan is to have the plant up and running in commercial operation in 2024. Our plans for Germany are, of course, a bit more ambitious than just one plant. So our intention is to have a total ash treatment capacity of 300,000 tons per year, end of this decade. The second installation we have in the pipeline is located in the west of Sweden, in Helsingborg. The treatment capacity of 30,000 tons of ash is more or less the same. And here the basic engineering has already been finalized and the permit application has been submitted last year already. And here we also expect a startup and commercial operation date in 2024. Our concept foresees several ash-to-phos installations with capacities between 30,000 tons or 90,000 tons per year ash treatment. And our ambition is not to transport chemicals through the country. We bring the ashes where the chemicals are, which means that the plants are favorably located in chemical industry parks, where most of the chemicals are available in large volumes, and in best case coming from the pipe rack, so that we really just have to transport in the ashes from, let's say, across the country. Having said that, we are producing 15 to 45,000 tons of our PCP, precipitated calcium phosphate, per plant. And besides that, also recover coagulants like ferric chloride or aluminum hydroxide, or can even upcycle it to sodium aluminate, which can then also be used in different applications. Besides that, also one big part of the ash is the silica sand, which can be used in construction industries or even can be considered for glass production. The heavy metal concentrate, which of course is the price for a pure product, has to be landfilled. But overall, the whole concept taps more than 95% of the total ash matrix in different products, and therefore is a concept of real waste reduction and closing loops in a large scale. Having said that, I thank you for your attention. And if you have any questions regarding our technologies, please feel free to contact me or my colleagues in Sweden. Thank you.